Hey guys! Today we are going to talk about bonding and nomenclature. Let's start from the very beginning. What are ions? Ions are atoms with a charge. They are created when an atom gains or loses a valence electron. Gaining a valence electron on a neutrally charged atom makes the atom negatively charged because the electrons are negative. Losing an electron on a neutrally charged atom makes the atom positively charged. Negatively charged ions are anions, and positively charged ions are cations. For example, let's take a neutral sodium atom with 11 protons and electrons. It will become a cation, a positively charged ion, when it loses an electron, written with a superscript as a positive sodium ion. And now, let's take a neutral oxygen atom with 8 protons and electrons. Gaining 2 electrons will make it an anion, a negatively charged ion, called a oxide ion, written with a subscript as oxygen 2 ion. You can determine the charge of an ion from the periodic table by looking at its group. Groups on the left-hand side gain and make positive ions, while group on the right-hand side make negative ions. For example, groups 1 and 2 is more likely to lose 1 or 2 valence electrons than to gain 7 or 8. Therefore, ions from those two groups will always have a positive 1 or a positive 2 charge. This is a positive ion, which is a cation. On the other hand, for example, group 6 and 7, atoms will always gain 1 or 2 valence electrons rather than to lose 6 or 7. Therefore, ions from those two groups will always have negative charge of 1 or 2, which is a negative ion, also called an anion.
What is ionic bonding and how does it happen? An ionic bond is an electrically neutral chemical bond between a metal and a nonmetal created through the electrostatic attraction between positive and negative ions. It happens due to an element's desire to have a completed valence shell. To illustrate, let's take an element like sodium from the alkaline metals in group 1 located on the far left-hand side of the periodic table. Sodium, like all other elements from group 1, only has one valence electron in its outer shell. To have a completed outer shell, it is easier for sodium to lose an electron rather than to gain 7 more. On the other hand, let's take an element like chlorine from the halogens on group 7, located on the far right-hand side of the periodic table. Chlorine, like all other elements from group 7, has 7 valence electrons in its outer shell. To have a completed outer shell, the easiest way would be for it to gain 1 electron rather than to lose 7. When sodium loses an electron, it becomes a cation, a positively charged ion, because there are more positive protons overpowering the negative electrons in the atom. This sodium atom can be written like this, Na with a superscript plus sign. When chlorine gains an atom, it becomes an anion, a negatively charged ion, because there are more negative electrons overpowering the positive protons in the atom. This chlorine atom can be written like this, Cl with a superscript minus sign. Taking these two elements, since one is negative and one is positive, they will want to bond with each other because opposites attract. They will bond to create an electrically neutral compound called NaCl or sodium chloride, also known as table salt. Another example of an ionic compound can be magnesium oxide, or MgO. This compound is created when magnesium loses its 2 valence electrons to have a completed outer shell, and hands them over to oxygen, who just conveniently needed 2 extra electrons to also complete its outer shell. The positive magnesium cation then attracts the negative oxygen anion, making MgO. Always remember that a metal will form cations and nonmetals will form anions. How do you draw ionic bonding? Well, there are 3 steps to drawing an ionic bond. First, we must look at the formula because it tells us how many of each atom to draw. Second, we can draw an electron dot diagram showing the transfer of electrons from metals to nonmetals, which looks like this, similar to a Rutherford-Boers diagram. But just to simplify things, we leave out the inner shells in the drawings and only focus on the outer valence shells. We can also leave out the protons and the neutrons for the nucleus and just write the abbreviated element name in the center. The last step is to add the charges to the drawing, which is how many electrons are gained or lost. For example, taking a look at Na and Cl again, you must first crisscross, which is the technique used to get the formula, which is Na1Cl1. This is saying that you have one Na atom for every 1 Cl atom. You will draw something like this, Na plus 1 because it is in group 1 and will lose its 1 valence electron, giving it 1 positive charge, and Cl minus 1 because it has 7 electrons and will gain 1 valence electron, giving it its 1 negative charge. Now you can write Na and draw 1 electron around it, and write Cl and draw 7 electrons around it. After that, you can draw an arrow from the Na's 1 valence electron to the empty valence electron opening, and Cl indicating that Na's valence electron has moved to chlorine's outer shell. When you do that, Na becomes a plus 1 charge because it lost an electron, plus 1 Na, and Cl becomes a minus 1 charge because it gained an electron, Cl minus 1. This is simply showing the bond. It is saying that we moved a valence electron over, and these two superscript charges are what's pulling it together. Another example can be K and S, potassium and sulfur. K needs to lose the 1 valence electron in its outer shell, so it is K plus 1, and S has 6 valence electrons in its outer shell and needs to gain 2 valence electrons, so it is S minus 2. Now you crisscross the superscripts and get the formula K2S, which says that for the potassium sulfide, we need 2 potassium atoms and 1 sulfur atom. Now we can draw the 2 Ks with their 1 valence electron and draw the 1 S with its 6 valence electrons. After that, we can draw arrows from both of the K's valence electrons pointing to the empty valence electron openings in S. When we do that, because the potassiums lost their 1 valence electron, they now both have a plus 1 charge, plus 1K and plus 1K. And sulfur, gaining 2 valence electrons, now has a minus 2 charge, S minus 2. How do you name ionic compounds, and why do we use Roman numerals for some compounds? Well, when naming ionic compounds, we put the metal first and the nonmetal second. For example, calcium chloride, CaCl2. Ca is a metal when it comes before Cl, which is a nonmetal. Additionally, in a binary ionic compound, or a two-element compound, we must remember that the names of all two-element compounds all end with the suffix "ide." For example, NaBr, the compound between sodium and bromine, is called sodium bromide. Additionally, we know that the element contains oxygen if it contains the suffix "ate", for example, calcium carbonate. And we note that the element is acidic if it contains the suffix "ic" or acid, for example, hydrochloric acid. We use Roman numerals for some compounds because some cations can form more than one charge. Roman numerals clarify which charge of metal that forms more than one charge or cation has. Some metals, like iron, for example, can form a plus 2 charge and a plus 3 charge. These Roman numerals clarify which charge a compound has. This specific example, the iron in iron oxide has a plus 2 charge. So the Roman numeral for iron is 2.
Other than ionic bonding, there's also covalent bonding. Covalent bonds form between atoms of nonmetallic elements. In a covalent bond, the octet rule is satisfied by atoms sharing electrons so that each can have a full outer valence shell, which means they bond so that their outer shells overlap so that they share the same valence electron and have full outer shells. For example, to form water, you need 2 hydrogen atoms and 1 oxygen atom. The 2 hydrogen atoms need 1 more valence electron to complete their outer shell, and the oxygen atom needs 2 more valence electrons to complete their outer shell. So the outer shells bond so that the 2 hydrogen atoms are sharing their valence electron with the oxygen atom, and the oxygen atom is sharing 2 valence electrons with the 2 hydrogen atoms, 1 valence electron for each atom, which in result makes them all have full valence shells. Another example would be 2 oxygen atoms bonding to complete their valence shells. Oxygen atoms need 2 more valence electrons to make their outer shell complete. So both oxygen atoms combine so that they are sharing 2 valence electrons with each other, thus giving them the 2 valence electrons that they need to complete their outer shell, which is 2, tri, which is 3, tetra, 4, penta, 5, hexa, 6, and so forth. The mono prefix is usually not used for the first element in the formula. The O and A endings of these prefixes commonly are dropped when they are attached to oxide. Through the prefixes, you can figure out the formula of the covalent bond because you can see what the compound is and how many bonds are made. For example, The compound pH3 is called phosphorus trihydride, as there are 3 phosphorus atoms in the compound. However, atoms that have a full outer shell, such as neon atoms, don't need any bonds because it already has a full outer shell. Prefix names are used for covalent compounds. The prefixes used are mono, which is 1, di, which is 2, tri, which is 3, tetra, 4, penta, 5, hexa, 6, and so forth. The mono prefix is usually not used for the first element in the formula. The O and A endings of these prefixes commonly are dropped when they are attached to oxide. Through the prefixes, you can figure out the formula of the covalent bond because you can see what the compound is and how many bonds are made. The compound VH3 is called phosphorus trihydride as there are 3 hydrogen atoms in the compound. Therefore, hydrogen would become trihydride. Here's another compound. SCl6 is called sulfur hexachloride as there are 6 chloride atoms in the compound. Therefore, chloride would become hexachloride.
In conclusion, ions are basically atoms with a negative or positive charge. This happens if an atom gains or loses an electron. Positively charged ions are called cations and negatively charged ions are called anions. And you can determine the charge of an ion from the periodic table by looking at its group. There are 2 kinds of bonding, ionic bonding and covalent bonding. Ionic bonding is when 2 ions of opposite charge are attracted to each other. Covalent bonding is when 2 or more atoms of nonmetallic elements bond together to complete the outer shell. The number of electrons required to fill the outer shell determines how many covalent bonds an atom can form. Okay, that's the end of this screencast. I hope you learned something. Bye.
Bye.